Just look at this picture. I thought this picture was very moving, how they superimposed the actual pilots on the back of it. I thought this was really neat. It's one of the books that I actually bought when I was in England last time, and there's only one problem. We went to pack our suitcase again and found that we had never taken it out of the suitcase. And what it is, it's Spitfires in American markings. And I thought, well, shows you what I know, but this was a great little book. It has some really nice photos in it. And I always thought one of the things would be really cool is doing a Mustang in British trim and a Spitfire in American trim. That would be kind of a unique thing. Anyway, just a thought. Now, I didn't get a chance at the end of the last video, I didn't get a chance to document some of the things. This is from Chris Jackson, and Chris was calling me every day for a while he was working on his Spitfire project, and he sent a video even of this. And a lot of little details, but I want to just run through these pictures quickly, give you an idea of what a good, I think he did a fabulous job. Boy, he sure captured the look with the tiger mouth. But when I looked at this the first time, I thought he went up in a Spitfire bedroom and stole my model. This is from Chris Jackson, and the video that he sent was excellent. We were watching it in his shop the other day extensively. Here's quite an Air Force. I know Joe Adamusco will be impressed. I will try to see that he gets a copy of this video. Here's the ace on the tail. Looks like he's got some kind of tricky linkage here for the Raby rudder. And I will definitely, Chris, pass some of these on to Stunt News. I'm sure he's going to use them. This is one of the nicest renditions of the Spitfire I've ever seen. He even did the radiators on the bottom. He even did the, I don't know where the retracts would go, and that's kind of prototypical. He went with the thinner invasion stripes. What a nice ink work. Rivet lines. Looks like he has a removable tail wheel. I'm taking a wild guess. No captions on the pictures, but I can pretty much figure this out. And this looks like a totally different model, but it's got the Canon details and everything on there. From Chris Jackson. Anyway, absolutely beautiful. And appreciate it a whole lot, and we have enjoyed every minute of that video, trust me. Everybody here enjoys swapping videos. And just let me invite you, if you've got a camera, access to a camera, run over and take some pictures of your Air Force, your plane, your wife in a bathtub, whatever you think can turn us on here at the shop. One of the next projects we need to make up is the pushrod for this plane. Just want to run some thoughts here. We have the traditional pushrod that you make when you make any plane. No adjustments anywhere. One of the things we've had on several past planes is adjustable ratios. This plane we don't have at this time, but because we have access to the controls, we can go in and add a bushing anytime we want. If we have a tail horn, when a plane is a take-apart plane, and this is what we have now, if we need to extend this or add a bushing, it's very easy to do because it's a take-apart plane. It gives us that option. Now, adjustable slop would be that one of the holes between the pushrod that goes from the flap to the elevator would have an 1/8 inch hole and a 3/32 rod, and it would create some slop. Without that slop, I've found it very difficult to trim a plane to fly level. If a plane doesn't fly level, usually putting more slop in will help up to a point. We've also included on some of our ships an adjustable length pushrod, and that's worked well. That's worked great for fine-tuning. But again, because we have a take-apart airplane, in a matter of 30 seconds, and we did it last year at the Nats, we can just take the pushrod out. So what you see here is, on a traditional plane, where you have to cut the fuselage apart and drill holes, and, well, we've kind of left this in the past. We don't do this anymore. We have 3 possibilities here that at some point in time we want to try different ratios, and we have that ability to do that. We just take the tail off the plane, drill another hole. We have adjustable slop, and the way we put the slop in the plane, I'm going to detail that out right now. And we have an adjustable length on the pushrod. Now this is the little gizmo that Bill Biles sells, which is an excellent little thing. If you have one of those, that's a great way to do it, but there's even another way, is make an adjustable pushrod with a solder slip joint, and once you find where the plane flies in dead neutral, just make another pushrod without the joint. And that's what we'll do here. We'll try to set it up for pretty close 0-0, but somewhere down the road, if we need to make it, we'll just make another pushrod. It only takes me 15-20 minutes to make a whole pushrod, and that eliminates one of the joints in the control system. Some thoughts that I've had, things that I've found over the years that seem to be very, very significant. Number one, if everything is lined up, if the wing, the motor, the wing, and the tail are all in absolutely perfect alignment, you probably don't need a lot of slop in a plane. Maybe you don't need any. I'm not sure. This is an aerodynamic thing that has many sides, and I can only give you my opinion. My opinion is that all planes should have some slop. So what I have is on my flap horn, the hole that's going to go to the elevators, this hole is an 1/8 inch, and it has a 3/32 rod, and that just allows a little bit of slop. But now you have to line everything up in neutral. Well, when my flaps are in neutral, I want to be sure the elevators are in neutral. Well, how do I do that if I have a slop? Well, what I do is I take the pushrod end and put a little piece of fuel tank tubing over the end, and that lines up in my horn. Then I line everything up, and then I take that little piece of tubing off the pushrod and solder it. And this gives me just a little bit of slop, and I found that amount is a real good starting place. Now, some of the reasons that you might need this. Look at most planes, and you go to the center of the wing, you notice that the drag, parasitic drag, is not equal top and bottom. So let's pretend that you built this plane and you decided, well, gee whiz, for flying at my flying field, I need bigger wheels. Well, now you've made it even worse, because what happens? All of the parasitic drag is below that center line, and what it's trying to do, it's trying to constantly change the trim of the plane. If you were to add something to the top of the plane, let's say you've redesigned a canopy for a larger canopy, now you've added more parasitic drag up here. And what happens is now the plane will not turn equally. A good example of that is most planes, when you put wheel pants on them and then take wheel pants off, you have to readjust the handle a little bit. I found it's a very significant thing to get this drag lined up so that the plane tends to fly neutral. Now, if it doesn't fly neutral, if this picture that this is running into, it's wanting to nose this plane down all the time it's flying. The bigger you... Pretend right here you had a little parachute. Well, that's what that little... You're trying to equalize the pressure on, and that's what a really good design, a design that evolves over many ships, and basically the Cardinal, Strega. You can figure out where and when this could be. Now, it changes in a lot of ways. If you, for instance, make the landing gear longer, that parachute just got twice as big. If you've decided, well, hey, my custom plane, I'm going to have this, the Willie the Whale canopy on it or something, you've just changed, and now you have to basically go back to where you've got to get it to self-center again. Now, if this was all done ahead of time, and you were building an exact plane that had already been built many times, and you knew exactly which wheels went on it, well, it'll be fine. But we never do that. We're always building something new, and that's the fun of the hobby. So we want to be able to adjust this. And one of the things that allows us to adjust is if we put a little bit of slop in the horn, it allows us to have the elevators in neutral and the flaps drop down just a little bit in level flight and in inverted flight equally. When it's done equally, our flaps will have a little bit of travel up and down, and the elevators will be in neutral. So it allows us to compensate for the fact that this might not be exactly right on a brand new prototypical plane. Use a Nobler as an example. What slop also does is as you make the slop bigger, if you go bigger than 1/8, and I wouldn't think you'd have to, maybe something really needs to be cut and changed if you have to go more than 1/8. But if you do, one of the things that, it's pretty obvious to me what has to happen here is, if this ratio, let's just make a number up, is 20 degrees, you've got 20 degrees of travel to do a corner. When you put slop in this, you're going to allow this to go maybe 25 degrees. You're increasing flap travel every time you increase slop. The exact opposite is true. Now, you can compensate for that, and all these people on the market, they have horns shaped like bananas and things like, with every shape and size, and yeah, that stuff is all rocket science, but it doesn't take into account the slop factor. The slop factor, to me, is a significant thing, and having the horns at cocked angles isn't a very insignificant thing. It's like if you're going to run a race and you wax your shoelaces, yes, you'll run faster, but if you tie your shoes, you'll go even faster. This is tying your shoes. This is stuff that really does matter. Now, what happens is as a plane gets heavier and heavier, let's say, as an example, you have a 50-ounce Nobler. Well, you want a lot of flap travel. And trust me, the heavier the plane is, the more you want flap travel. A real light plane, probably like a Billy Woolwich plane. In fact, I even think he wrote in his article to minimize the flap travel. And that's true. But most of us don't build super light. You build at realistic or heavy weights, and that's where it comes in handy to have slop. Because the slop, if you start with a 1-to-1 ratio, it's going to allow the travel of the flaps to be a few degrees more, and that usually generates more lift in the corner, especially if you're going to tape the hinge line shut. And the end result is you have a very easy way to test this. You can put that little piece of fuel tubing back on this so that it is now symmetrical and there's no slop. Fly the plane, go in, take the bull bottom hatch on our Typhoon off, put that back in, take it out, and see for yourself. And that's always the best test of all. The best test of everything that I've ever done. And I always tell people, it's nice to call up this person, that person, call up Wendy, call up whoever, dig up Abraham Lincoln, whatever you have to. But the bottom line is the best test of all is try it yourself. See how you like it. Also, when a plane doesn't turn equally, when it turns, let's make a whole new storyboard. I was going to try to do it with this one, but this is such a significant thing. Paul Walker wrote about this in his Impact article. If your plane tends to make nice, tight little squares, but on outsides it's really mushy like this, well, you want to adjust the pushrod length. And a lot of times, you can do this a very easy way. You can just make another end for the pushrod. You can cut the pushrod end off where that little piece is. You can also buy that little Bill Biles adjustable thing, which is a handy on-the-field adjuster. That's a good way to do it. But my first choice on doing this is just to have the whole new pushrod made. And an even better choice, and it's probably the choice I'll wind up with, is to have a pushrod half of the wire thickness longer, half of the wire thickness longer, half the wire thickness thinner. And then by adjusting the push rod length, as you make the push rod shorter and shorter and shorter, you're going to, or longer and longer, you're going to adjust the ratio. If you shorten the push rod, this turn is going to get tighter at the expense of this one getting bigger. Now, Paul Walker wrote about this on his little trim thing, and it's an excellent thing to refer to. But this is all part of having all these adjustments. If the plane is a one-piece plane, some of these you have to make hatches for and other things. But if you have here's the bottom line. A take-apart plane, it's like having your cake, like having your push rod and eating it too. You have all of these possibilities because you can get in at it, make a new push rod longer and shorter, adjust it, adjust the slop. You can do all these things, and that's why I say over and over and over again, it's a pain in the neck to make a take-apart plane. It takes a lot of extra labor, but somewhere down the road, it pays dividends. Well, you know what? Right now, as we go, and we'll probably make the push rod today, the dividends start to pay back. And that, to me, is what's worth it. One of the other things that's worth it about a take-apart plane. The things I've kept in the shop for a long time. This is a spare push rod. You can see how we put a little detent in here on the end that we're going to solder. Leave enough wire sticking up here. We'll do one of these real quickly on video. But having this joint here, this allows me, first off, to put the plane together and get some idea of what the overall length should be. Now, the end that's going into the front hole, I need to put a little piece of fuel tank tubing on here so it'll center it back to zero. Now all I need to do is, this is going to give me my slop. It's this little piece here that's going to give me the slop. It's just with a parting wheel, cut off a piece, 1/8 of an inch or so. And this is only going to be, the only reason I'm going to use this little piece is to line up the flaps and elevators. Once I think they're lined up, I take this out and this self-centers my push rod so that the slop is the same amount up and down. It's just a spare piece of common fuel tank tubing. The first thing we need to do is figure out where neutral is. I haven't made up the permanent wires yet for this, but what I want to do is get the flaps in relative neutral here. And then I need to pin them in place. Now what I can do if I'm really in doubt is run a parallel line, and I've already done that with the rivets, so I can see, get this exactly zeroed up into neutral. I have both sides pinned, and I have the push rod just attached with that little piece of copper tubing in it, and what that's going to allow me to do is just get a rough idea now, and I mean the roughest of ideas, when I put the stab in place, if I need to make this a little longer, a little shorter to start with. But I'll always have that little ability to fine-tune it by heating that soldering joint. When I get it right, then I'll just make a push rod. And then that'll be my neutral gauge, so to speak. Okay, now that's hooked in. Now, the push rod's installed up in the front. We need to just bolt the tail in place temporarily. I use the same little aluminum washers from Micro Fasteners. The address is on the previous video. And now I need to look in and I can see how much longer or shorter. Just make sure this is in, it hasn't changed. Now by looking right in there, and let's see if we can do this on camera. Let's quit fooling around. We can look right in there and see how much we're off by. I would guess, it's not like we're off. This is our go, no-go gauge. But this is our, I'm going to guess, a 1/2 inch. So I need to make my test push rod a 1/2 inch longer. And then I can make my 2 gauges to line up the elevators. I have that. I can reference off the rivet lines. And when I take out my little piece of brass, everything should line up perfectly. Famous last words. You ever done one? You know that never happens. Okay, now I can just take an eyeball guess of how long that piece has to be. I don't even have to solder it. I could CA it. Because I'm just making, see what I'm doing? I'm making myself a pushrod length gauge. Put out this way, roughly. Actually, if you didn't want to make a test pushrod, you could just use a piece of 3/32 wire. Okay. First step is to make 2 pushrod ends with a precision drill. Since we use an 093 wire, I want to use an 093 drill. I want a tight fit, but not a fit that's so tight that I crack this part when I put it in. Now, a couple of things. When you're bending a pushrod wire, you don't want to get a perfectly kinked bend. You don't want to have this be such a 90 degrees. You don't want to put it in a vise is what I'm saying. You want to have a little bit of a radius out there. Now the same thing, I'm going to make up the 2 little pieces of wire, the extended ends. These are the ends. I always bend them this way and then trim them off rather than trying to bend it so small, because we only want just a little bit to stick up out of the pushrod. This is the primary end. This is the end that's going to wind up going in the front of the plane. And what I want to have happen here is I want to have these are the little, there's going to be double wheel collars holding this on, so I want to have this little knurled part so that the little set screws can drop in there, and I'll have redundant system double. And I want to have the hole in the pushrod here so that this will slide through, and then I'll trim it off. Key part here is to leave enough sticking up. This is on the end that's going to go in by the flap one, and I want to wrap this with CA and carbon fiber. And that's just a little reinforcement because I have seen these break after a plane's in service for quite a while. You see they split the long way. You get plenty of thin CA down in there so this gets nice and solid. Now we're not going to do this exact thing on the other end because we're going to want to use this as our fine adjustment. But this end will be permanent now. We can make this a permanent end. What makes this possible to get a fine tuning on this, you can see what I've done is elongate the hole where the wire is going to slip through on this side. This is the side that's going to go on the elevators. Once that's through, and you want to make sure some of that is sticking up, of course, now I can push this in. Now this hole's just tight enough that I can move this. You can see what's actually happened. I have a fine adjustment, and once I get this in place, I'll set the elevators, which will set this right about where I think neutral is. Then I'll lock it with 1 drop of CA. Make sure everything's in neutral the way I want it, and when it's done, I'll fill this end with thin CA and wrap this with carbon fiber. But this will give me that final fine-tuning adjustment that I can find dead neutral on. And then I just need to wrap both ends with the copper, with the carbon fiber. Copper fiber, that's a new word. Yeah, this is just a test fit. I know I have the flaps locked in neutral, and I have the elevators, because I know this is a flat tail and it's at 0, and I know exactly how much it should be between the elevator and a straight line, a parallel line. So it's this little dimension, and I have no slop in the system now. This is at neutral, this is at neutral. Now I can take the push rod out and lock it in permanently. I've had that little adjustment. I've got this fine-tuned, and it is as close for a starting point as I think I'm going to be able to get. I can lock it in, and then carbon fiber up the push rod. Now that I've established the length, I can take this little piece of tubing off. I probably have to pull it off with pliers. I had it forced on. And that'll set me the clearance that I want. In the other end, I'm ready to wrap with, I put CA in there. I'm ready to wrap this end with carbon fiber and dress it off. And that'll be our test push rod. Now it's best just to tack, and I shove that piece down into the little cavity there, and then wrap the toe. And if you don't have any of this toe, I can supply it to you, because usually you have to buy a big giant roll for a couple $100. You can't buy small amounts, and I'll be glad to share it with you. But this just keeps the end, and if you didn't have toe, one of the possibilities would be just wrap it with copper wire or string. That would be a little bit heavier. Some fiberglass thread. Now once you get to the end, here's where it gets tricky. You want to hold that and point it down, otherwise the CA runs. And just let that sit and kick without kicker. And then of course I'll dress it all off, sand it down. And one of the things you can do is dress this off, just hit it with another coat of thin CA. Don't breathe the dust in, of course. Anytime you're sanding carbon, you want to wear a mask. And this pushrod is ready to install. We'll put double wheel collars in by the flap horn, solder the back, and that'll make sure everything's still at 0, 0. Next thing I'm going to do is solder a little washer on here with a little copper wire safety, so that even if the solder joint fails, in theory the copper wire would be a redundant system. See the wire, that's my redundant system. Stay bright silver solder, deflux it. Now the tin foil is always a good idea because some of the flux can splatter. And I would always notch the wire and just put in a couple wraps of the thin copper wire and deflux it with baking soda and water. Well, it looks like we've been relatively lucky. I put the real wires in here, took those ones that were oversized out. Looks like we've got some really nice control movement. And the next thing I want to do is, I want to tape the hinge. I just put them in this position. I lay the tape out on a table and strip out a piece. This looks like about 7/8, 3/4 of an inch wide. So I strip this off with a razor. Of course, it's way oversized. I want the controls totally deflected in the opposite direction. And when I take this off, of course every time I remove the control surface I have to take this off, but a little bit of heat with the heat gun a la John Brodak. We have the little hook in the wire here so that it can't walk its way out. Now usually there's some noise or whatever you want to call it in the very beginning until that works its way in. And see, it goes away eventually. But with this system you really have to tape the hinge lines. Now we got the hinge lines taped, the controls finalized, and this is possibly the smoothest set of controls I've ever made. That is trying to piece this together here. I have a little bit of time left. I'm going to get the tail section on with an aluminum bolt and set up the Ray Brother linkage next. I'm trying to dope this out in bite-sized pieces that I can handle. It is the first time it's been buffed, and actually, get out of here, all in one piece like this. So you really get a nice overview. You can see the finish really is nice. Anyway, instead of belaboring a point, what I want to do, I want to get busy. Maybe I can get even more done. I want to get that tail section and the Ray Brother linkage set, and I'll feel like I really have accomplished something today then. And the controls are just as free as if it had, a whole season of flying on it. Well, as we were with these hinges, getting the epoxy out, this still seems like they could be a little bit freer. So what I'm going to do is put a little bit of 3-in-1 oil on here. And if that doesn't free them up, a little bit of penetrating oil. See, because now the pockets are relatively sealed. And as careful as you are, you just never can be too careful. That epoxy has a way of working its way in. But I think we have a nice, oh, that's better. We have a nice set of sealed surfaces now. Now the screw that I'm going to use, the screw that will be the actual screw we're going to fly it with, will be an aluminum 440, and we'll use one of those aluminum washers. Now here's a magic trick. We're going to make the tail appear. Abracadabra. For a magic trick. This is just about the, well, as nice as I've ever seen it go together, because we haven't seen it all together in one piece yet. I guess after all the hundreds of hours of work, I deserve a little walk around here to look at this guy in one piece buffed out. Oh, except for the nose. We're going to do the nose last. Okay, now next thing I want to do, I want to set this linkage up. And I want to set it up so when I'm in neutral, I have just a degree or two of offset. And on full down, I have maybe 10 degrees, something like that. And that's basically a ballpark starting point. From there, you'd want to, of course, try a little more, a little less, and see what kind of results you get in terms of performance at the top of the hourglass on a square 8. But that, the Rabe rudder always seems, Rabe rudder I should say, always seems to be a valuable tool. And now that we have it on Miss Ashley too, we should be able to use it to our advantage at points, in, especially with using bigger and bigger props. And we assume, we don't know if this is going to wind up with a 4-blade or a 6-blade or a 16-6 or what. We have a whole lot of uncharted territory ahead of us. I've been trying to work out, I want to be able to get the ball link on and off, and we've allowed for that. But I can't get I don't have a tap, so I can't thread both ends, so I'm going to have to put a slip joint in here somewhere and cut 2 pieces with thread so I have threads on both ends. And that looks like it's going to be easy enough to do. And it'll also be removable. You'll be able to just, I want to have this accessible at the field. I don't want it to be a pain to get at it. Just I made it oversized so I can shorten it. And shorten it. Now I just need to do a solder joint on this head. This is probably the easiest way to do this. Now linkage the right length. What I'm trying to do is, of course, deforce the joint, polish this up just a little bit. Try to give it a finished look. We are closing in on actually, I didn't think I'd get this much done today. Even a little detail like this, I think, is, you know, it just makes the plane look finished. It makes it look like we care about even the smallest detail. Again, I'm looking for, these are the things that I'm careful of, that I don't have this rod running into this in the end, because we have that half a fillet in there. I don't want any, actually if I use this hole, I'll have to bend the rod a little kink in it. I don't want to do that though right now. But that's about how I've set it up to begin with. And of course that's always adjustable as need be in flight. I want to do some dry fitting up on this engine combination. First off, I need to put on, before I do anything, I want to switch to the prop, the thrust washer if it fits, that has the pins in it, the one that Bob Zambelli made up. This may have to use the puller to get it off. Well, I'll spend the rest of the day doing up some dry fitting here. I want to look at how I'm going to have to take the muffler and tank all of these components apart when I go to do maintenance on this. And I want to see what the spinner, well, the first thing is I want to put that, I ought to do it in order. This is the motor. This is one of the few modifications we're making to it. One modification is to loosen the two carburetor screws and move this over so it sits almost in the center of the model now. Just make the linkage to the carburetor a little bit easier. The motor's already broken in. And I need to remove this with a puller. And I have one that Bob Zambelli made up that he turned the diameter down to fit inside our spinner back plate. And also at the same time, with a precision jig, made 2 pins so that we can possibly upgrade the ability of the motor to, if it backfires, to loosen the prop. Like everything Bob does, it's really world class. Nice little accessory item. The jig block, the adapters, and some aluminum washers with knurls, real knurls. You know, once you have this, you need to be able to drill a spinner back plate and everything a precision fit. You just can't put 1/8-inch holes on this. It'll be sloppy. You want a nice tight fit once that's put on a motor. To show you what a precision fit this is when you get this on. Wow, that really socked up nice. And now I just need to do the prop. That much should at least help lock it in place. All the props we use, once we have the back plate, and we're going to buy a couple of spares, we'll have the tool that Bob came up with worked real well. We half relieved the prop. And we need to key it in exactly so that it doesn't hit on the detents. It's such a tight fit. In fact, I may have to go 1 drill size over because it's a tight fit on the pins. 1 drill size oversize, and that keys right in there. Now we have a whole keyed unit. As long as I'm setting up Bob's little jig to do these props, I may as well get a couple of spares made. These are the 14.5 rev-ups. These are the ones, and we'll balance them, of course. But these are the ones, well, once they have this little modification in the back, they'll be ready to use on the Typhoon. And if we break all 5 of them on the first day, shame on me. And once we decide to start experimenting with props, each one is going to now need that little detent. I think that's a good safety feature. When doing all this bench running on 80s and 70s and 90s and 65s and all of these engines that we've been playing with, one of the things we found is that the Satos especially are not real critical to exhaust tuning. They're probably made for mid-range, cam timed or whatever. They seem, very uncritical to the exhaust system, which is a real plus in this case, because what I did, I wanted to just snap the whole Typhoon together, basically because I just want to look at it like a voyeur tonight. I haven't really ever seen it all in one piece yet, and so I wanted to put the muffler on and put all the hardware on the spinner and balanced up a couple of 14.5 rev-ups, and I thought, well, this weekend I may shoot some pictures of it, so I'd like to. Of course, it's going to have retracts right now because it has no landing gear. And if we hand launch it and land on the scoop, that'll be fine. But anyway, one of the constant maintenance things is just keeping the muffler clean. Just for my own personal, I just like the way it looks better. And the aluminum that Sato uses, it buffs up on a buffing wheel real nice too. First I get all the oil off. This is one that's already been run. Well, I just, in case we do get time to take some pictures, again, I like everything polished and neat and clean. I want to show you how quickly you can buff up a Sato muffler, though, because the reason is it's really good aluminum. Look how quick that buffs up. Only going to take about 5 minutes to do the whole thing. And choices we have is to try some different exhaust systems. We have a 90, 91, 72. See, one of the unique things is I have to be able to keep the oil away from the area where the Z-tron is. So that's one of the things I got to be careful of. I got to kind of take it into account. And it's nice that these engines are not real vertical. Otherwise, we'd really be in a little bit of a bind. Just look how nice this polishes up. So that is, it adds a nice touch.
Will travel melts like a lemon drops high above the chimney top. That's where you find the old star.
Now, as planned, within our major plan, we could use the wider muffler. We really have just enough clearance, though, really not a lot, so I would have to get ahead of it with a little less bend. This is a 90 that I have on here. That's the one Warren Walker made up. But this is the first time we've had it all together, so we're being a little bit of a, just critique. Starting to really get exciting now the last couple of days. We got to make the gear up. We have to fit the Z-tron. I made a little list of all little things left to do. Got to get myself a pair of wheels. Figure out how and where we're going to mount that battery pack. What angle you look at it on. This is the first time I've actually, in the last 5 minutes, the first time I've ever seen this all buffed out in one piece like this. The most impressive part to me is the way the nose section came out. And the finish is, the Brodak dope finish is absolutely beautiful. It remains to be seen whether people are going to have any appreciation of the airbrush work. We're certainly going to find out. Anyway, I got my list together and we're going to look at making up the final little parts for this project. And boy, from this point on, it really does. This is one of the impressive things. It's how nice the controls came out. They're just sweet. This section I like with the manifolds, the filters. We don't know which muffling system we're going to use yet. But I had the vision when I started this of getting a whole 4-stroke, the whole 91 inside the cowl. And trust me, it's in there. There isn't even a hole for anything. And after so many 100 hours of work, it's really, really nice to be able to see this guy all in one piece. And the last thing is the gear, and we are going to try to make a pair of really scale gear so that when it's sitting, it'll be sitting up high on the gear. We can taxi it around, land it on the gear and hold the tail wheel up. Anyway, been a long day. We'll be back to this. I can't wait for tomorrow. It's this kind of a day. It's the kind of day I wish would never end when you get to this point. Hey, been a lot of hours to get up to here. And I guess it's in the eye of the beholder how much it looks like a Typhoon, but to me it really has the look of the look that I was originally striving for. Anyway, see you tomorrow. I'm beat. Today I want to get the landing gear roughed out anyway. And what I always do is I save all my old landing gear legs from, these are some spares we had for the Spitfire, for a couple of reasons. See, these are Spitfire gear, and they're different lengths, so I can get an idea now, because I know I want to have clearance for a 15-inch prop. So I can just use these just to plug them in, since all my landing gear plug in the same. And it's a good idea to have a spare, or even to bend a few. We could even use these spare wires we have here, and some different size wheels. Now we're hoping to use 2.5-inch wheels, 2 1/4. I don't know. We're gonna be looking at all the possibilities here. But the first thing I want to do is put on the shortest set of gear. These are the shortest, and I think these are the longest. These are the longest. So I can just plug them in, so I can get an idea of how much prop clearance I have at this time before I bend up my wires. And this would apply to a wooden airplane, it doesn't matter, any airplane. Gauge. I have a piece of tape on here so that I can measure how deep into the wing the wires go. Okay, and I can pretty much get a gauge on 1/16 of an inch less, so I'll adjust the gauge. Now the way I bend up the wires on all the planes, pretty straightforward. It would work on any plane, work on a Cardinal, an SV-11, any plane that you want to have wing-mounted gear to track real nice. Remember, we have 2 landing gear blocks in here, so I want to make sure I'm getting into the, gotta do a little, there we go, where it's sitting in that block. And what makes this system work so well is that we have 2 blocks, and we have plenty of leverage on the wire. Now I can get a rough idea about what my prop clearance would be. This will give me a relatively accurate, because it helps if you don't have a bunch of paint down in the little recess. You've got something down in there. Now the prop clearance changes. Well, we got something down in there. Maybe some Bondo or something, I don't know. I'll have to clean it out. Anyway, we have a lot of choices here. Just by changing a wheel, we could get more prop clearance, or by bending the gear back. But we have a real accurate way, since the plane is all in one piece now, a relatively accurate way of getting the gear angle figured out before we actually go and make the gear legs up, even though we can change it later. It's nice to have it real close on the first flight. With this gear length, they're definitely not going to have enough prop clearance. So I'm going to go to the biggest ones, and if anything, I'm just going to wind up with this, because we don't really know if we're going to wind up with an even bigger prop. I'm just going to make them to the longest length of the landing gear. All these gives us a real good idea of where to start with our gear leg length. Of course, you could do this on the plans, but then you never really know. You can't take into account the amount the gear flexes, or where the CG is, where that angle on the gear is going to wind up. So this is for me a more practical way to do it. So well-used wire bending jig. We have 3 of these. We got these from John Brodak, and they work to perfection because they put just enough bend in a wire that you never kink or fracture the wire because of the radius on the pin. Again, available from John Brodak. This is the heavy-duty one because we bend horns with this. Jimmy uses it when he runs production runs of 1,000 horns. This works perfect. Wired, a couple of things. You don't want to bend it any further than, I said wire, not birds. You don't want to bend it any further than you have to and then bend it back. You'd like to bend it right up to the point, especially on control horns, things like that. But anyway, the leg that's going down into the wing, we don't care about the length. We'll trim that off to our gauge. But I always put a piece of tape on here because this acts as my go-no-go gauge, and wire always springs back. So if you were to just measure 90 degrees and bend it, it's going to spring back. You got to, according to each piece of wire, you got to kind of It's hard to explain until you've been disappointed a few times. Now I'm going to estimate what I think is going to be my spring back here. And what I do, you can make all kind of dead stops. And this can move. That gives me a little bit of a... Now, I take this out. That looks like it's not 90 degrees. Let me get a triangle. And which is probably going to tell me I got to move that tape just a little bit. Yeah, see, I'm less than 90 now. So what that's going to mean is when I come around, okay. I want that tape to move just a bit. Let me get it off. Listen, now this won't really be super accurate. I've got to do this every time I work on something, and I'll move it to there. Let's see. And if that works. I think it's safe to say one of the jobs most people really don't enjoy. Now see, I'm still not quite 90, so what it means, I can move the tape even more. But eventually I'm going to hit this, and then I'll bend a fresh piece of wire. This is just a sacrificial piece of wire. And see if I have, once I establish a 90-degree bend, the rest is relatively easy. Now let's just see if we can get it. Now that's too much. I can see that already. So we need to go back. Now when we're doing production things, we make a little dead stop and hot stuff it right in place. But first we have to set up where this particular batch of wire is going to bend at 90 degrees. Now the one thing I'd never want to do on a part we're going to use is bend it back. Well, this piece now is toast. You start with the other end of the wire. Once you get a 90-degree bend, you are pretty much on the way to success, and the rest of the landing gear bends are kind of easy to predict. Eventually, if you go back and forth, and that looks pretty good. What I have is a piece that I know fits into the wing, and I'm looking down at, because I have to allow for the wire being pulled into the jig, and I'll make this will just be a test. So let me just, and then I can adjust it longer. You know, you're always going to have to bend a few pieces of wire. With that test, I'll try to line this up and make another 90-degree bend. Then I can adjust that line. Just allow that the wire shrinks. Now it looks like I'm on the long side by 1/16 of an inch. So what I can do is adjust my angle right here. This is now. Now it's always good when you're bending wire. Once you get done bending it, bend a couple extra sets. The reason is we want to ultimately, we probably won't do it right now, but ultimately make a set of grass gear or whatever. Now I can see by how much longer this is than this one, and adjust my dead stop. I have a pretty good idea of getting those first two bends. We just leave that oversize and trim it to match. We know that's going to be real close to 90. And I know when I put this back in here, at my second mark, and once I get this right, I'll bend up a couple of sets of wire. And I've got the first two bends now, and I can do this over and over and make a bunch of these. Effective prop clearance, and one of them, of course, is the wheels. We save all our wheels for just such a day so we can decide which set we're going to ultimately wind up using. I got the two wires bent now. It's the angle forward that's going to determine the ultimate prop height, and I want that angle forward. I have a very specific thing in mind when I do that. I want to have it that when I put the nose of the plane down and I let go of the tail, it rests back. If it stays in that position, the gear are too far back. If it just drops like an anchor, well, you can figure it out. We're looking for a point where we just let go of the tail and it just drops down very casually. Now we'll start by eyeballing down here and seeing that I can see this wire is further forward, so I need to take that one, bend it further forward again. And then we'll flip it up on a table and check for the clearance. And the wires, and see that they're both relatively parallel. In fact, the back one's got to get bent just a little bit more forward. And then I'm ready to do my test. And boy, this works on any plane. Gets it almost perfect on the first shot before you ever even fly the plane. I found this to be the absolute key to getting it set up right, and this is for tar. For grass, I like the gear a little bit, maybe a lot further forward, depending how rough the grass is. This is a 14-inch prop. That looks like we would have enough, except we're not in a level takeoff mode, since we're going to want to run a takeoff, and that only gives us a 1/2 inch. Well, not crazy about that. What I ought to do, because this is a critical adjustment, and that's probably a little bit down. Okay, I'll make the next set of wires. I'll keep these as a spare set, make the next set 1/4 inch more. But this is the test. And this is the critical, this is the tricky part. The plane is on its nose. You let it go and the tail comes down slow. Now see, that's too far back. If that didn't come down, means we're close. See how close we are? We need to go just a bit further forward. But the other thing it's telling us is we want to for sure make the wires 1/4 inch longer, because that'll allow us to bring them further forward. So now we know the two critical things. Make the same set of wires up 1/4 inch longer, and maybe 1/4 inch further forward, and then we'll keep this as a spare set. So we have all these dimensions written down, and we have our test gauges, making up the next set of wires, and we can do a fine-tuning on them relatively easy. And I want to show how I adjust the leg length. To replicate a set of wires, I have all my dimensions, and this is why I always bend an extra set, because while you have this all, see, I've written it all down over here, while I have this all fresh in my mind, it's easy to make another set. It only takes a few minutes more. But if I have to reset this all up later on, because I want to make grass gear or a longer set, a shorter set, it's a nightmare. And just having this ability to do this accurately, relatively quickly, we know that goes to that mark, and we can make a set of wires up. Now whenever I mold the landing gear covers, like on a Spitfire, I always like to use somebody else's wire so they can make all these fine adjustments before we do the molding on it. Okay, now I know I have this. I want to go to 4.5. You notice that I'm using, let me do it so you can see it without that piece in here. This is my leg length now that I'm adjusting, and this is a real good way to do it. I butt this up here, and I find the center of the wire at 4.5. I've got it written down because I'll forget. At my age, you forget everything. Now, this was 4.5. Now I want to make it, let's add 1/4, let's add 3/10. Let's make it 4.8. And that should give us enough clearance, and that we can move it a little bit further forward. 4.8. And this will work every time. And I know that 4.8 is the amount I want. I can get rid of all these other numbers. And I've got all the marks, all my gauge marks. I can make sets of wires up in a matter of seconds. Here I have the original piece I made, which I used to get my top angle, not the angle, my top length. I can line this up this way. I get it right pretty much every time. Famous last words. Amazing when a camera's running how you can't get anything right. Okay, this is running. So I think one of the worst jobs of building a plane, I think these tips will help you, I hope so, and give you an ability to make an extra set. For instance, if you know you're going to make the same plane next year, you may as well make up 2 or 3 extra sets right now while you have all those marks on the jig. Sure, even if I decide to go to a little bit bigger wheel, that I have enough length here, so I'm just going to add 1/4 inch to the length when I cut that off. Give myself every possible choice right up to the time we fly the plane. Now I know the angle on this is a little bit too far back, so the wire that I'm actually going to use, which is a little bit longer, and what I did, I made 2 sets. I made one even longer so that I can make up a set of grass gear where it tilts even further forward. You see the angles I'm trying to line up? I'm trying to get these to line up and my new wire to be maybe 1/4 inch further forward. I can see the angle is just a little bit further forward, which is what I wanted. Now I can take the original test piece out and match the matching leg to this so that I have the 2 new matching legs. I've got the angle just right. There, I'm for all intents and purposes done with my test wires. These are just going to be spares. I'll take the wheels off and put them away because I have a set that matches and I have a set of spares. And these 2 exactly where I want them. Now what I want to do is I want to take the spare set of wires, which will be my tar gear, and get them even, that they're just about maybe 1/4 inch further back. And again, I'll take one out at a time, replace it, and match the other one. Angle set on both sides. Now the key is, and this is really one of these hit or miss things, I want to lay a straight edge right across both wires and check that they're not towed in and towed out. I want them to be in alignment with the lead out so I can kind of hold I'm in the midpoint on the lead outs, run my 48-inch straight edge right down the wires and tweak them. Not much more annoying than when you have a ship that you're going to take off and it either wants to steer in at you or steer away or do one of these dog shaking the tail things. And what I found, 2 things really important: slop in the wheels, a little bit of slop so they can self-center, because it's every time you move the lead outs you have to move the gear to a certain amount. And I've had planes that when you move the lead outs back or forward it would land or not land the way I wanted it to. So the first thing is to get the front to back. And we go over to the vise and see this one here is okay, this one needs to get bent in. In other words, I'm checking the dimension top to top, front to back. Those are the 2 dimensions I want to have so they're not in any way out of alignment, and the ruler will get it set for you right away. I have a nice vise handy. One of the things I've done in the past to do little tweaks. Again, anytime you make an adjustment, is it correct in this dimension? And if not, you need to do a little wire tweaking. It looks like we're close. Just one more little tweak. Sometimes this tweaking can go on forever, but once you have it right, I'm trying to anticipate a little bit of an angle because of the lead outs. We're at midpoint right now. And we'll just hope that if there are any inaccuracies in this, that we'll make up for them with the slop in the wheels. That's like the same as the slop in the controls. If you have tight wheel bushings and they're out just a little bit, either towing out, you just go put some slop in the wheels, those are the plane will land like it's on rails. The wires, at least for this point in time, bent for a good medium point for the first flight. What I want to do is I always remove some of the material. I don't touch anything on the torsion arm, but this piece here I can relieve some material. We don't need an 1/8 of an inch wire right here. And I want to roughen up the part that's going to go against the door legs, make it as rough as possible so I get a good glue grip. It is really a pain to me because we do a lot of landing on grass. When these start to split and then they break, and it's a weak link in the plane. Anyway, you can always get some material, nothing near the bend. and nothing near the end. Almost the same as a control horn leg. Anytime you can get a gram here, a gram there. I don't want to make these weak, I just want to make them rough. The more little flat spots I can put on it, rougher and better, especially down at the end where they're always prone to crack. Now, one of the defining features of the Typhoon is they're rather big, larger than say other comparable things, the wheels and the large gear doors. They really rake forward too quite a bit. Kind of a neat shape, especially when they have the invasion stripes painted on them. And ours, of course, will have the invasion stripes. A wealth of photos to work off, so this should be relatively realistic when we're done, I hope.
I know.
Go look at this side at some of the details. A real large photo enlargement that I can get some of the details that I'd like to replicate off. The door shell, very similar to a Spitfire, where it has this little lip and edge, and we'll try to replicate that. This view here gives us a good look at what that should look like from a detail point of view. This will be real handy. It also shows us having these planes, of course, where the scissor is, which we want to replicate the scissor if possible. So let me get out my artist sketch pad and try to work out that shape and do the fudge thing to try to get it in the right proportion to the plane. Little patterns. In fact, I made a lot of little patterns until I was kind of happy with the shape. I like the way the wheel exposes at the back and the strut doesn't come down the middle. So I try to get most of all the aspect ratio right. Then I went over to the plane, which is sitting on the floor over there, and line it up and see if it looked right. It looked about right. I had it taped in position. So now what I want to do is cut a couple of these out of 64th plywood. Now the trick with the 64th plywood is I want the grain, there'll be two laminates. I want the grain going in one laminate this way and one this way, so that the part is in essence 6 layers of plywood with six different layers and some grain. But I don't want them all going with the grain in one direction, because then they turn into thin little oil canny things. Next piece, I have the grain going in this direction. Now I want to take the same piece and just glue the piece itself to the plywood with the grain going in this direction. If you try to make two pieces the same and then glue them, it really gets difficult. This is an easy way to get two pieces of plywood to laminate, and then I'll trim it back to the shape of the first part. I want to get a good laminate here, because this is one of the parts of the plane that takes a really tremendous beating. And boy, when they don't hold up in service, and you're always fixing them and then they get oil soaked, what a nuisance. And the grain is oriented in 2 different directions here, so this should work well. Of course, then I just want to dress the last little bit off. So this will now be a 32nd of an inch thick. And I've got the multiple grain, so it's relatively rigid. Now the next step on this is I laid out where the wire is actually going to go, and I want to just tack glue this on so that the wires are in position while I work on the detailing. One of the critical steps, just getting this at exactly 90 degrees so you don't have two giant trim tabs and letting that glue just tack up without any kicker. I want that to be, in two reasons. The other reason is if the wheels are going to be tracking crooked, they're going to wind up hitting this. So this is important, getting this at 90 degrees. I know it's 90 degrees. I ran the whole glue seam up there. I know I have that little piece of tire exposed. I checked on the plane to see that it would look about the right proportion and scale. So I'll just replicate the other one up in that same dimension. I want to get in that groove because I'm going to make up some detailing on this. But I want the whole leg, to have the whole leg covered with glue, just to make it a little bit stronger. The next thing I did, I took a piece of aluminum tubing to simulate the real axle leg, and what I'm doing is I'm trying to carve up a piece of dowel into a half moon. Of course, this won't be exactly scale, of course, we just want the look so that the half moon dowel will fit over there and cover the wire. Quick, when you're doing good little tip, take our little Bud McKnight sanding sticks, take off a little piece. When I want to get in corners, angles, and edges, this just makes getting the seams relatively easy because we're trying to detail this up. As soon as that edge wears out, just clip off another. You can see the part that's worn out. The rest is always fine. Now we're not making an exact scale copy of the gear like a scale ship would have. What we want is something that looks like this plane would possibly have. That hollow dowel, you can see how much I hollowed out of that dowel. That seemed to work pretty well. With some soft aluminum tube, ordinary hobby tube, and I want to make some, let's see if we can get 2 slices of this off. I want to make the equivalent of replicating the scissor on this. Now you can just simply trim this. Make it a little bit oversized to begin with. Like I said, don't let it go. Good thing we don't work in a dynamite factory, huh? And a little half moon that comes off with just a little bit of adjustment, let's say. And I can come up with some spacing on this before I glue them. This one needs the edge trimmed. But this gives it a 3-dimensional look, and then we're going to make the V part of the scissor here out of plywood. And just hot stuff those in place. Now just the slightest bit of sanding to dress this off. Make sure our primer will stick well. The next thing, I want to lay out the scissor. I'll lay it out in multiple sheets of the plywood with the grain going in different directions and just cut it out. It's like doing a cockpit detailing, just making a lot of little parts and trying to make them as realistic as possible. thing nice about the plywood with the grain going in different directions, you can grind it, you can detail it very easily. Just these little toothpicks, and I thought, well, it's a little bit easier to make that scissor with pieces of toothpick, just easier. I just happen to have them sitting right on the work table. Now you get that one tacked in, and then I can kind of lay this. This turned out to be a little bit better way of doing it. I can simulate that scissor. By adding a little washer, it adds a little bit of the realistic look of the scissor. Just an ordinary little 080 washer. I've been with a combination of tools trying to get some realistic looking lightning holes in here. Before we put the outer skin on. These are all little subtle touches. And once that outer skin is on, I gotta dress this off. Once that outer skin is on, it'll give this a real three-dimensional look. Circle template, of course, is one handy way to just make this a little bit neater, or you can freehand it. I tried to freehand this in so I could get a good spacing on the circles. What I did is I made up a paper pattern so that I could transpose. Otherwise, how do you get the... See what happens when you go to do it? It's a problem. So this way I can transpose some of these so that they're symmetrical. Now once I just glue this on, I'm going to leave that little edge, which adds a little touch of being prototypical, just to maybe 32nd of an inch around the whole parameter when I trim this off. Block sand in that last little bit. Now just after a final sanding, these will be ready for a coat of Rodak primer. And then we'll let them dry overnight. I just want to dress the corners off. I don't want to have razor edges on this. Okay, that's ready for some Rodak primer. We'll get a coat of Rodak primer on this tonight, sand it tomorrow, get another coat on, get it all nice and smooth, and then we'll do the painting. Quite a day. I got the white on, and what I'm trying to do is lay out where the invasion stripes will be from looking at the pictures and then from going and matching it against the plane. As if these doors really closed, I used the same invasion stripe width, so it should look pretty realistic. I need to back mask this. It looks like we have a sprayable day, and just spray this area black. Make these symmetrical too, if I can. once this dries, we'll get a couple of coats of clear on this while we have some good drying time. Okay, we found so many good little uses for this water airbrush. You don't have to mask the other side because there won't be a lot of overspray with this. And it looks like the weather is such we'll be able to put some clear on this today. Now also in today's mail, this is the spinner to Al Rabe's Millennium Mustang, and you can see it's quite an intense spinner. To give you an idea of how big this is, just get a look at how it is relative to a spinner. This is the spare spinner. One of the spare spinners that's going to go on a Typhoon. Take a look at the size. Now this is really, I'll tell you, you could kill somebody if you throw this at him. It's as heavy as a pineapple. What I'm going to try to do, most of the weight is in the back plate. Actually, almost all of it's in the back plate. I don't know how much you could get off of the front of this. But what I wanted to do, I wanted to make a carbon fiber back plate for Al as part of his Millennium Mustang project. We'll see if we can mold him up one in carbon fiber. The molds that we've made in the past, and we've made hundreds of these. These are the carbon fiber Aero and True Turn, and we have one for a Russian spinner that we get hardly any orders for. We're going to make something similar to this up, but look at the difference in size. It's a tremendous difference in size. So what we're going to have to do is, first thing we're going to have to do is come up with a base plate big enough to mount this. And I have what's left of this piece of glass. In fact, I'm looking for a clean corner. I can work off of this corner here. I need to clean this up first. And I want to try a little bit of an experiment because Al is, of course, going to want this part back. Now, if I glue it to the table, which I normally do, then I'm pretty much sacrificing this part. It would have to be put back in a lathe and trued up, cleaned up. I'm going to try mounting it with rubber cement because all we need to do is seal that back edge. And this is kind of an experiment. If it doesn't work, then we'll have to go ahead and sacrifice Al's back plate. And one thing I've noticed, it's always easier to spend other people's money than to spend your own. So let me give this a try. This is a good time to try it. This will be try to get some of the rough spots off. Because what we want to wind up with is the top side of this to be a perfectly flat surface. And I'll take a rag with some acetone, try to clean the rest of that off. Actually, this is going to be big enough. The base plate, in this case, I'd like it to be as clean as possible. And glass is always a good base plate, assuming you have it, because it's expensive. You just don't want to take it and throw it away. We try to use it over and over again. And maybe that's what, if this rubber cement doesn't work, then I was thinking a second choice would be contact cement, because then I can take it apart with heat. By heating it, I can take it apart. But we'll try the rubber cement first, just as an experiment. And even at this, I put some M600 on here too, just so we would get a reasonably good, as we've used this glass about 40 times already. Again, since we've never done this before, sounds like something from my teenage years. Did you ever do this before? Now, if this doesn't work, like I said, we have a backup. The backup thing is going to be, but first we're going to, and this will have to be put back in a lathe and trued up on the back, something this big. You wouldn't want it out even in fact, you'd really want to even statically and dynamically balance it too. But I'm sure Al knows all that by now. Having used these big spinners before, I'm sure he's got this technology down pat. Anyway, if they ever go through with their Martin Baker project, they'll need something probably pretty close to this size spinner. And the deal is you just let this kind of kick off. Now let's just see.
But the heights were too high.
Because that back surface ultimately will get machined, I guess we don't have to be nutty crazy about it, but
Oh, I was
now wherever there's none, see, I'm inventing this as I go along.
far from history.
I want to get off all the rubber cement I haven't used. Well, I just heard a great thing from Ed Gallagher. He says anybody making carbon fiber parts, they have a new system that the RC Jet guys are using, is they mix ambroid cement with Brodak dope. Can you imagine? And they make the bonding primer coat with a mix of ambroid cement and Brodak dope. Now, even I never thought of it. I know Grigsby and these people like that, they'll be thinking about that. Now, because we want to save this part as part of our, and if you could see how heavy this thing is heavier than you can imagine, so, but of course it's probably designed to be used on a Quadra or a lawnmower engine or something, submarine engine. Now we won't need any release agent because we're going to use 910 rubber to make this mold. Well, what's nice is anybody from this point on decides to make a Millennium Mustang, we can, for a very reasonable price, yet to be figured out. This part would probably be 3 times the cost of doing a smaller one, probably in the $20 to $30 range, because you're using a lot more. You probably use a half a yard of material putting this together. Okay, now I have to build a dam around this. I'll do that with balsa wood. Be worth trying. I have a bottle, a jar top that I can cut the whole middle out to make my dam and save a little bit of, well, it'll just make for a nicer mold too if it works. Again, this is the kind of stuff, if you experiment and it doesn't work, the world didn't end, you just go make it the traditional way. We're trying to learn something. Yeah, we're going to find out if this is a practical way to do this. Hey, what do you think? Columbus went to a travel agent or something? Yeah, put me up on Santa Maria. You think I was going to edit that off the tape? I'll just add this to Al's bill. Anyway, it's not funny. Well, it could scare you to death when these saws come apart. But the point is, this, if you can make these spinners and make them light, it opens up the door to a lot of projects, a lot of exciting projects. That Martin Baker project might be one of them, where the thing that keeps it from being a possible practical project is you can't buy a spinner in a store. One that doesn't weigh 10 ounces. All I need this part for is to make a dam. Now, other ways of doing it would be you could just go buy some modeling clay. You really don't see, we're trying to use inexpensive materials here, and that's what makes the projects possible. If you're going to go get this stuff made at Boeing, it's going to be a fortune. A part like this would be $1,000 if you had somebody do it in industry, but you can probably do it yourself. Don't try this at Home Products, like this jar lid. Actually would work here, and I just thought it would be a piece of a PVC pipe. And I got to tell you, a true story. I know Al probably won't mind me sharing this, and let's face it, he has no choice. I'm going to tell it anyway. He sent me a set of plans to one of his planes, and it was rolled up in a piece of PVC pipe. I couldn't believe it. I said, whoa. It was like $70 to mail it or something, I don't know. Nah, it was, but when I got the PVC pipe, I thought, what the hell is in here? It caught me off guard. Anyway, I'm going to build my little dam up here with just ordinary pieces of duct tape, because all I needed to do is just not leak the rubber out. And we can do this, I'll do the rest of this off camera, just with little pieces, and then connect them and put a piece around the whole perimeter. You put the duct tape on, it doesn't have to be fancy, it just as long as it doesn't leak. Find a place where this is relatively level, and I'll check it with a level, but then I'll need to be able to shim it. So it's on a part of my table that I know is relatively level. Otherwise, this is going to all pour out one side. I'd like to have this surface relatively flat, just as a reference point. And now I need to mix up the molding rubber. This is the material of choice. It's about $90 for a container like this, and we'll get many molds out of it. But it's not out of the range of the average hobbyist. It's certainly not in Boeing territory. Right on the can lid, it tells you, stir well before using, and they mean it. This is a 10-to-1 mix by weight, and you've got to be accurate. You just can't be sloppy and go, about. You've got to do it with a gram scale if you want this to come out to its best properties. And it's a little on the sloppy side to work with, so we usually wind up trying to be careful anyway, not contaminate the whole place. Now I need to get a stick. You can see how if you didn't stir it, see the marbleized, the parts of it that aren't totally homogenized. We allow about 10 minutes for this homogenizing operation. And even if you put this material away for a couple of days, you need to rehomogenize it. But what happens if you don't? You'll get little spots, bubbles in the mold where it isn't catalyzed. And I want to stir it. Notice how I'm stirring it. The reason I'm putting this on video is I'm trying not to ingest air into it and make bubbles. Bubbles are your enemy whenever you're doing a rubber mold. You always want to stir slowly and get whatever's up along the edge of the lid and down at the bottom. And with a paddle like this is the best way I know to do it, or even better, a big wooden spoon. But you don't want to do is try to do that operation where you're ingesting air in it and you make nothing but bubbles. Because we'd like to have no bubbles at all on the final part. What we need to do is weigh our empty cup, which should be, if everything is normal, it should be 12. Get an accurate weight on that. It looks like we're going to need about 300 grams of this, roughly 300. We'll fill that mold. Have a poured or mix this. An easy way, again, this is one of my plugs. This is actually the plug to the bottom of the Typhoon. But it makes a good paddle. And it's an easy way to kind of meter out. If you try to pour this like you would pour a cup of coffee, you're probably going to pour half of it, and you can't stop it from pouring. That's the other thing. It can really be embarrassing. Try to fill in using this kind of a method. And by the way, each time you do this, it just lets the air be relieved out of it. Now, since we can't fill it to the top because we need to put 10% of it as catalyst. Between 300 and 400 grams, I think. Just an eyeball look at that. I'm going to guess that'll be enough. And one of the things I want to say, I really appreciate the fact that Al has put so many of the things that he's done relating to the Millennium Mustang on videotape. Because that's the medium by which I've found you can help the most people most of the time. Printed stuff is nice. It's cute to be an author, but a videographer has a much bigger gun with much bigger bullets. You're able to influence people and help them. Okay, now we've got, I can see 500 grams on this, 490. We need to put 49 grams in there. Now I know from the past that isn't going to work. I'm going to have it overflowing. So what I need to do is take out a little bit of material, which I'll do. See, and this is where the paddle comes in handy. It's funny now, I bought a bunch of videos from Fiberglass, and I thought, oh boy, these are professional people. They're wearing white suits and they've got white gloves and they're working on a clean linen table, and I didn't learn one thing from that video. It was like I just may as well have given them my money. You got to show the things that people run into problems with, and one of them is any rubber mold. The biggest problem is getting air bubbles in the mold, or mixing a tremendous amount. Okay, now we got 397. Now I can put the correct amount, 10% of the catalyst in here. Now, the trick with the catalyst is you want to measure out. In this case, it's 397. So I would normally add a little under 38.7 grams. I'll calculate that out and set the scale at that position, and then just keep dropping in little bits until the scale zeros. The scale set to 0. We've got it set to the amount. And what I've found a good way to do this is to pour the catalyst in the cup. So if you go over by a gram or two, you can just add the equivalent amount of the molding rubber. But once you figure out all the little bugs of doing this, making those little plugs, and we're going to use prop resin. We're going to use EPON 862 when we make this part. It'll be a post-cured part. It will not be made out of, the stuff they make boats out of, or cosmetic parts. It'll be a structural epoxy. Here it comes, here it comes. Well, okay. Now the trick is, very, very slowly and for about 5 to 7 minutes, stir this. Biggest mistake you can make here is whip it. Put it in a blender. It takes about 5 minutes. You got to stir it slow so you don't get any bubbles. Even stirring it this slow, you get bubbles, but you want to minimize the bubbles. And you can see, I don't know if you can see that, it's starting to get into suspension already. But we'll do the rest of this. You'll be bored watching me do this for 6-7 minutes, and then this will be ready for our pour. So now we're ready to start this pour. Starting a pour, what I want to do is get a very small amount down in all the little cavities. You don't just pour it in like you're going to pour a milkshake, I guess. I want to try to work this into all the little cavities. Again, a nice part about molding with rubber, there's not one part of this that an average person can't do. There's really nothing high-tech about this. Making propellers, making tune pipes, making hard molds, yeah, that gets intensive. But molding rubber is like a great entryway. And the parts you get, like the Typhoon cowlings, they're just cardinal cowlings. Those parts are just as good as if you had made them from hard molds in every way. Except that it doesn't cost a whole lot for the tooling. It doesn't cost thousands for the tooling. And the reason I'm doing this is I want to get all the air bubbles to bleed up. A good way to do that is with a little bit of heat. The heat will usually, we want the bubbles to all rise up off the part. And what we'll do is we'll pour a little bit more, do the same thing, a little bit more, do the same thing. See the bubbles already coming up? The same thing, we're trying to just let the air bubbles evacuate. 912 is a really easy material to work with. You can get a container like that for just a bit under $100. People are very good with tech help, and you'll get several molds for that amount of material. Doing it in layers. This is about the 3rd or 4th layer, I think. Just trying to get all the air to come up off the part. Hit it with a little bit of heat, just a bit. You could vacuum bag it if you really want to go into the aerospace industry. In this case, for this kind of a part, I don't think it's real necessary. Just pick the bubbles away as they come to the surface. And is take an extra piece of duct tape. In fact, it's a piece with the 2 sticky sides together and just a little lip sticking out at the bottom with the glue, so that I can, rather than throw this material away, I can just add to the volume of the mold. And I'll still have a flat surface on this end. It'll just make for a thicker mold, a little bit more rigid. Now I wouldn't make it any thicker than this if I didn't have the material mixed. I just miscalculated and mixed up too much material. But again, nothing's hurt here because it's going to dry. We leveled this table. It's going to dry on a flat plane, and that's what we want, is for one side to be flat. We only need one side to be flat. And while Al's mold is curing, and that usually takes 24 hours, we have some other work to do on a Typhoon, including finishing up these landing gear. And since we have a great painting day at our disposal, one of the things we want to do is get some clear on this, and then kind of do a little fit to see if we've got all our angles and wheel clearances right as soon as the clear dries. To be a nice day here. Let's see if we're going to have a lucky day painting. It's a warm day out here. I'm trying not to get, there we go, not to get a run. I think these are going to be a relatively nice addition to our Typhoon. And they capture the look without being overly heavy, overly complex to make. You certainly could make a set in one session. Now we'll get 3 or 4 coats of clear, Brodak clear on here, and then buff them out, and we'll be ready to install the wheels. One more of the final little touches. In today's mail from our good friend Lieutenant Colonel Tom McLean, who is making a copy of Daryl Greenemeyer's privately owned world record-holding jet. Now this looks like it's really a unique plane. Look at what the tail is. Be very interesting to see how this works out. Of course, Tom really is a real Phantom F4 pilot in real life, so as he loves the jets, he made that great copy of Harold Price's plane. And he was a big help to Bill Hummel when Bill Hummel wrote which soon will be appearing in Stunt News, the tribute to Harold Price. Now I'm assuming this is his workshop. Looks pretty neat, pretty military-like. I don't know, Tom. This looks like a little too clean for my taste. I like to see some dirt. Anyway, this plane has an anhedral. Looks like it has an anhedral anyway. The tail-mounted real high. This will really be a super plane. Really looking forward to seeing this. He says he's going to have it ready for Brodak's. Just one more good reason to make it up to Brodak's. Anyway, we really look forward to seeing some more pictures of this, Tom. I know you've been looking at a lot of videos lately, but we need to see it finished. Has, by the way, in real life, it has a red, white, and a multicolored paint job. Really exciting. It was a privately owned jet that at one time held the world speed record by Daryl Greenemeyer. And if you go back into the jet era, when everybody's vogue thing was to make the planes look similar to jets, my sweeper is an example of that. This was Harold Price at the 65 Nats. These photos were donated by Win Paul, by the way. And another picture here I have of the color is not a good reproduction, but it's a real picture. And this was Harold's, the last of the Valkyries, the pink and blue. And this color here really was light blue, but a really, really well-made model. This is going to be featured in an upcoming, very soon, Stunt News as a full construction feature. Also sent me a 1976 magazine
Steve Ashby, kind of a semi-scale looking Typhoon here. And of course we save everything relating to our semi-scale project, so we have a really nice library of stuff. And it won't be long. I'm just looking how he has the black stripe painted on the gear. We're going to finish buffing those gear out today. So look at his fuselage and cowl are a little more scale-like, much more like an Al-Rabi plane, wider, more to scale. Mine are just a little more traditional, but still a real nice rendition of the Typhoon. Made the little recess where the tail wheel would retract into. This is what we hope to be doing very soon. Our building season's coming to an end. Our flying season is about a week away, 2 weeks away. We really had a few days where you really could have gone flying. You just don't have the plane finished yet because of a variety of shop projects that we're working on. One of them being Al's big 3.5-inch spinner backplate. We're going to work on that today. Anyway, if you like semi-scale, if you like Typhoons, if you like stunners, there's just something here for everybody. Did a nice cockpit rendition with the British yoke. This was published in 1976, and if anybody's looking to get a Xerox copy of it, just copy Tom McLean. I'm sure he'd run you off a Xerox copy. But I'm assuming something that you might still be able to get the plans from Flying Models. 1976 by Steve Ashby. Looks like a really nicely drawn set of plans. But as I said before, we are coming up, look at the way he did the landing gear here. And he's done it just a little bit differently than we've done. Like see, with the 2-cycle engines, the nose always just, even my nose is too long, but with a 2-cycle engine, the nose just gets way out of proportion. I don't know if we've got that any better, but I want to see how it looks when it's actually flying. It'll be very interesting. Anyway, from Tom McLean, and we look forward to seeing it finished, Tom. Keep watching the videos, but not so much that you don't get the model finished for Brodax, and we'll definitely see you out at Brodax. Hope we'll see everybody out at Brodax. Anyway, the gear buffed up. They only need a day for the clear to dry to do a small part like this. Kind of a, I don't know, realistic enough to suit my taste for this part. And we'll always have the option at some future time of taking a wheel off and making a rubber mold of this part so we can replicate these. That might be coming up in the future. I don't know, but the problem why we're not starting to do too many of these little extra projects now is I really do want to finish the plane in as short a time as possible, because in this we actually are finishing this model a lot later in the season than we normally do. We'd already be out flying in the past with Miss Ashley and stuff. With Spitfires, we've already had 10, 20 flights on them. But I really want to get this in the air. I also want to spend some time with that throttle control. I need to learn how to fly the plane with the throttle control. That's a major thing I have to work on, and I won't be able to do it until I get some air time. So I'm going to mount the landing gear today, and then we're going to work on Al's backplate. Maybe we can actually get him a backplate today if that mold comes out okay. I know he's itching to finish his model up too, and I hope he'll figure some way of getting up the Brodax. Just to get us 4 little 440 aluminum screws, cut the size, put our little doors on. Oh, I hope I've got that look that it absolutely has the look of when that gear falls down. It picks up the stripe at exactly the right spot. And you could use steel screws, but I think for this application, these little spots, the aluminum screws are fine. I just need to trim them to about 3/8 of an inch. I'm trying to look at this from several angles just to see if I've got the look that I want. And I don't know. I wish I could have made the nose even shorter. Maybe that's coming on the next model that we can, once we see where this finally trims out. But the gear really did work out nice. That's one of the things I really was happy with. And the next thing is going to be, once we finish Al's backplate, I want to get the tank installed In the Zetron, the objective here is to have all the Zetron components down in this area so I could reach in, turn them on and off. Set that all up, see if that's going to work for me. Yeah, I think these gear are going to be fine. See, this is one of the things I like is you don't see the wire going into the wheel. I don't like when you see that wire there. We have the edge, kind of a prototypical thing. A nice clean solder joint, not a big chunk hanging out.
She took my childhood in her stride, and there are songs we cannot love. Oh yeah, I had a dream my life would be so different from this hell I'm living, so different now from what it seems. Now life has killed the dream I dreamed.
We certainly got the prop clearance part right. We have the angle just about perfect because we can't really do the final thing till we have the fuel tank installed. Until we mold up some nice four-bladed props, this will just live with our 14.5 rev up right now, but getting a road clearance on a 14.5 is not an easy task. I like the way, these are just some of my thoughts, I like the way the navigation lights looked. They do have a little bit of a prototypical look. I love the way the sub-rudder looks. Just some of the features I wasn't sure whether I was going to really like them or not. The nose art, where the needle valve is particularly nice because you don't get your hand anywhere near the prop. And of course we'll never be starting it by hand anyway. But not having to flip a prop and not having to put your hand by a needle valve certainly doesn't make your life any worse. I think we got the gear track and the spacing just about right here. Another significant thing. And if we decide to fly the team trials with this plane, of course we'll take the cockpit out. Possibly take all the electronics out because we won't be able to use them. That'll save a couple ounces. And we have the Zambelli exhaust system out being welded right now, custom little muffler. I really do enjoy after a very long winter, coming up on the point where we actually can start enjoying the things, the little enjoyable things about the model now. And that one of them is sitting here and having a cup of coffee every morning before we start our mold production. Just sitting here and enjoying a couple of different views of, as I'm sure all modelers do. Even Peeps, I think, enjoys it. And I think it's a fitting and a very nice tribute to Harold Price. And I hope it really, the people that have followed along with all the videos, that you've gotten some fun information and added to your modeling enjoyment. And if you have, then this project is a success for all of us. And like I said before, after a long winter, summer is coming. And we have production work to do today, so let's quit fooling around. Now we're going to work on Al's spinner back plate before we go on to the next project in the shop, because I'd like to make a little part up for Al and see if he can use it. And this is this is a really large back plate, so we're going to cut the material. I just got a fresh yard of carve it in here, and I want to pull this apart if you can see how I'm doing this. And there's the impression. There's the original back plate. And I would feel it's safe. Now you can get the rubber off with this, with your bare hands. In fact, we're getting so close to the end of this tape, I'm not going to lay this up until we start another tape. Because I hate to be in the middle of things. People always give me a, "You're right in the middle of doing something." Yeah. You know what, guys? Try shooting these tapes. It ain't easy. There's days it ain't easy being windy, and today's one of them. Now, it looks like we could trim a little bit off here. I'm not going to go too much. Just a little. But other than that, I think that's going to be a usable mold. And on the next tape, we'll lay one of these up. We anticipate within a day or two being ready to fly to Typhoon, and we have gotten some good weather, so we're very anxious to get rolling on that. Now notice I left this green lid in as a little reinforcement, so it gives it a little support. Now if we were going to make this a permanent mold and make hundreds of these parts, what I'd do is I'd put this in something and put some fiberglass cloth around it, so it would have like a garage. It would have a separate to hold it in confinement. But since once this piece comes out, what's going to have to happen? Well, I'll let Al do it, and he can make this as thin as he wants. He just put this in a lathe and run a tool across this, get it a little bit thinner or dressed off, because it'll have a Teflon edge when we're done laying it up. We'll do that on the next tape. We're going to start another tape probably later on today. I'd say that's going to work. And this adds another piece into our stunt history, our stunt puzzle, whatever you want to call it. Other people that are going to make a Millennium Mustang, this is just going to work great for them. Now, I really, truly do hope that you've picked up some good information from this video and from the other ones that we've made. Sharing this stuff, it's the love of my life. I really do love this event. I met with Joe Adamusco this week, and he is moving to his new house in August. He is as stoked as anybody I've ever seen to build something really incredible, and we laid the groundwork for what will be our next year's project. Of course, I'm not going to announce it here, but we're going to hopefully be able to team up on something really unique that's never been done in the world of stunt. It's been one of my dreams for a long time to do it, and it's only with his help and the help of Dave Downey that we possibly are going to get to that point that we'll be able to do these things that are not really practical or possible if you don't have the help of some real experts. And the help of Boeing, of course. Anyway, it's been a long, long, long winter as we've kind of got this guy put together. This weekend coming up, I hope the weather's good, but you never really do know. The weather is always unpredictable here. Anyway, just about 6-8 months ago, this was just a dream in my eye, and I didn't know whether I was going to be able to bring it to fruition. But it certainly looks like it's exceeded my wildest dreams. And I hope it's a really good tribute to my late mentor, friend, fellow modeler, Harold Price. Well, we'll see you on the next tape. See a shadow pass over and she'll which is best, a wandering fool or a heart of rain? I hope we're going to see you all at Bodex this year. Hey, and I just wanted to let you know one of the things we have coming. It's already been ordered. Paul Winter ordered is the 2000 Reno Air Race video and the Gary Levitz video. We have it coming. If you're interested, we might be able to loan you a copy. We'll see if we get it this week. Again, see you on the next tape.